Okay, so this is the video for the study guide for section 11. And before we get into all these problems, I'm going to go through just some formulas and stuff that you need to you'll have to really understand. So there's a bunch of area formulas for different shapes, and we've been memorizing those with the formula flashcards. So the rectangle formula, base times height; the triangle, 1/2 base times height; the square, s squared; and the trapezoid, 1/2 height times the bases added together. And then the circle, sorry, so there's kind of a lot for the area. So those are the key areas area formulas that you would need to really know for the test. And then for volume, there are 3 formulas they're going to give you on the sheet. It's just for prisms, capital BH, and these again are on your formula sheet, so even if I didn't give these to you, you'd still have these. I will put the area formulas on for the test, but you, again, won't have them for the FSA, so it is important that you know which ones go with which for the volume, because they don't tell you this information. They just put these formulas in this order. Okay, so those are the formulas that you need for area and volume. The reason the surface area is not included is because you can use area to find any surface. So if there's multiple surfaces, you just do the multiple areas added together. So, and then normally we're going to use Pythagorean theorem to find a missing side. So if we don't know a side, we're going to solve that using the Pythagorean theorem. So you do need to know Pythagorean theorem and when to use that. And then finally, for the end of the unit, we did density, which is D equals M over V. And we also did population density, which is the population density is equal to people over area, how many people there are for a particular area. All right, so quite a bit of formulas for this one test. But again, if you've been memorizing these, then you're well on your way, because one of these is going to get plugged in for the capital B. So really, I like to think of these B's as an A, because really an A is going to get substituted in for this. The reason I don't write it as an A is because on the formula sheet it's written as a B, so that you know that they're the same. So really you can think of an A in this formula, because A is going to get transported into this. So this is prisms and cylinders, sorry. This is also for cylinder, and this is also for cone. Okay, so those are the formulas, just so you have them all at the front, and then we'll apply them certain ones at certain times. All right, so number 1 is which solid of revolution is produced by rotating this. So if those of you that missed class on Thursday, April 8th, you missed the demonstration of this, so I will post the link to the video. It's like a 4-minute video just to watch. If you see it one time, you'll be able to kind of visualize what's going on. But really what's happening here is if the bottom was just a cylinder, so just a rectangle, then it would create a cylinder. So these two surfaces would circle around. We're rotating this around a line and create a cylinder. The top surface would also rotate around and create what looks like a cone cutout. Okay, so this one should be B. So this is getting spun around 360 degrees to create on the top a cone that's missing, and then on the bottom is cylinder. This one, if some of you guys that thought maybe it's C would be very close to this. The only difference is that this line on the triangle would need to be up against the line of revolution if you are going to get C. So the only, again, the top has it like this. This one has this, one of the sides of the triangle is drawn to this line. So this one would look like that for C. This one would look like B. It's going to have the cone cut out of the middle. Okay, D would just be a triangle spun. It doesn't have the rectangular piece, so this is what this one would look like. And then A, actually you can't really create A by revolving by any line, because if we revolved around this line, for instance, and originally the triangle looked like this, it would give us the shape here. if we did it around the middle of a figure that had a cone, like let's say it was like this, then it would be still symmetrical across the middle, and it's not. So it's just not A at all. Okay, so number 2, so a paper water cup in the shape of a cone has a height given and the radius given. The water in the cup reaches a height of 5 units. Okay, so normally we compare this scale factor. So the scale factor for this problem, because these are in inches, the height was in inches, or just units, not units squared, not units cubed, just units. So that would be our 8 to 5 scale factor. Okay, then we would normally get the surface area by squaring these, so 64 and 25, and the volume ratio by cubing these. So 512 and 125. Okay, so then the things that they want us to figure out is the radius. Well, radius is in units. It's not in units squared or units cubed, so it actually matches up with scale factor. So our proportion is going to involve scale factor and the missing dimensions for this problem. Okay. So we don't actually need the surface area or the volume because these are not surface areas or volumes. Okay, so when we cross multiply, we get 8r equals 20. So r would be, when we divide this, grab the calculator real quick. Okay, just want to make sure that was right. Okay, so 20 divided by 8 is 2.5. So the radius would be 2.5 units. Because it was one-dimensional, which means just units, not units squared, not units cubed, it goes with scale factor. Okay, on the bottom, which of the following describes what would occur if to the volume of a sphere if the radius is tripled? So the radius, remember radius is one-dimensional, so that really goes with scale factor. So the scale factor is tripled, which means 3 times bigger, or you can put 3 to 1. So they want to know what the effect on the volume would be. So radius is tripled. Typically that means that the volume of any shape is going to be, that's A, so A squared would be 9, and then A cubed would be 27. So anything would be 27 times bigger. The one tricky thing about volume is that if the volume is made up of multiple things besides just the radius, then you want to see if just the radius is tripled, then what the effect is. So the formula for volume of a sphere is this. So the volume of a sphere is this, and you're looking to see what is happening to the radius in the formula. So in the formula, the radius is cubed. So that means if you triple the radius, so if we triple the radius, that means because the radius is cubed in the formula, you would triple the effect. So you would do 3 cubed, which is 27. All right, just to make sure you understood that kind of concept, I did do a couple of examples. So let's say you just had a generic formula. Let's say formula equals a squared b cubed c d to the 5th e to the 4th. Okay, if they asked us, for instance, if they told us that c is multiplied by 4. And asked us what's the effect on the formula. Well, in the formula, c is raised to the understood first power, so that would just make the whole formula 4 times bigger. So you would be raising 4 to the first power. Anything times, it's just 4 basically. If they said b is multiplied by 4 instead of c, in the formula b is cubed. So that means you would cube the effect, and it would be 4 times 4 is 16, so 64 times bigger. So depending on what the exponent is in the formula, that's what happens to the effect. It's tripled or cubed or times to by itself 5 times. So that's how you can tell what's happening to the effect. Okay, number 4, the pyramids are given, and they give you the two types of pyramids and the height and the base. So the volume formula for a pyramid from the front is 1/3 AH, and A, which is 1/3 BH. The A is the area of the base shape. So we don't know the base shape. It doesn't tell if it's a square pyramid, a triangular pyramid. So they've actually just given us the B. So this is how the formula looks on the sheet. Sorry, 1/3 capital BH. So you would do the formula for the area of the base of the first figure is 52900, and the height is given as 147. So you don't actually have to solve anything. You're just plugging these numbers into the equations. And then for the second pyramid, the area of the base, the capital B, is 3025, and the height is 30. All right, so you would just figure out what each of those is. And I'm going to store this in spot 1, so I'll just show you how to do that because it's going to help save somebody else some time and be more accurate on the test. So you hit the store STO1, and that remembers the number. So even if you clear it and you hit recall 1, it brings that number back up, so you don't have to retype it in or round it or anything like that. Okay, the other one, if you do 1 divided by 3 times 3025 times 30, this one is 30,250. And I'll store that in spot 2. Okay, so I'll do this minus this because they want to know what's the difference between the volumes. So difference means subtraction. So we would do recall what was in spot 1, so this number minus recall what's in spot 2, and this is our answer. This one says approximately, so that's why these answers are rounded to the nearest thousand. Not thousandth, but thousand. So this 1850, that's end part, is close to 2000. So they rounded this up to 2000. So that's why it's B. Okay, for number 5, at a local Pets R Us, Robert brought an okay, so an aquarium shaped like a truncated prism. So basically, the prism has been cut. A truncated prism can be made by slicing a prism with a plane perpendicular to the base of the prism and removing the resulting triangular prism. So what they were saying is that this figure originally looked like this, but what happened was somebody removed a slice of it. They just literally took a knife and like cut this part off. So it's gone. So it looks like this. So they want to know now what's the area of the aquarium. So what's the area of the remaining piece? So you have a prism still a prism. It's just now a irregular kind of prism with like, it's not a trapezoid, it's not a triangle. It's close to those, but it's not actually. So the prism base is this. So when they ask for the area of the base, they mean the area of this figure. Okay, so you have a couple options to solve that. I'm going to redraw it over here though. Alright, so on the top, if we just look at the top figure, this 4 is this 4, so these are the same. This 4 is this 4, so we have 4s hanging off here, 20 and 30. We don't have an area for this kind of shape. It looks like a triangle, but it's not quite a triangle because triangles only have 3 sides, and this has 1, 2, 3, 4, 5 sides. So it's not a triangle. It's not a trapezoid. Trapezoids only have 4 sides. This has 5. So we actually need to cut it. Well, we could either, yeah, let's just cut it. So we'll cut it. Here, so that we have 2 shapes we recognize. So we recognize the rectangle and the trapezoid. Alright, so the dimensions of the trapezoid would be 20 here and 4 here. The dimensions of this is 20 by 4. The height of the trapezoid, which is this dimension, is 30 was the whole thing. This piece is 4 because it matches here, so this would be 30 minus 4, so this would be 26 for the height of the trapezoid. So to find the area of the shaded space, you would do the area of the rectangle, which is 4 times 20, and the area of the trapezoid. which is 1/2. I'll write the formula first. 1/2 height. The height of the trapezoid is 26, because remember we already calculated this area, so we don't want to include that piece. So we have 26 for the height, and then the bases would be 20 and 4. Okay, so the area would be 0.5 times 26 times 24. 312 plus 80. So 392. Okay, then they want to know from there the capacity. Capacity is fancy for volume. How much does it hold? So the volume of the aquarium is just going to be the area of the base, because it's a prism. And we already found the area of the base. This was 392. So we just have to times it by how tall the prism is. And how tall the prism is not always a vertical length, but it's the distance between congruent parallel faces. So 25 is the height of the prism. So when we multiply those, that'll give us the volume of the aquarium. So you're finding the area of the shape, but it's irregular, so you have to cut it. It's like our in our notes when we did composite area. So really, you will want to go back through and study through these notes, because so we did a bunch of area formulas at the very beginning. Zoom out slightly. But we also did composite area. So we had some shapes that were kind of weird, and we had to break them up and find areas. So you do need to practice. You do need to know how to do that. And sometimes we had where we removed the shape, so we subtracted the areas instead of adding them. So if you have not already, you do want to go through, just look at the notes, make sure you understand where we got, understand each section. All right, so number 6. Okay, so number 6 is the beast of the test, of the study guide. The harder, to me, the most time-consuming probably, and hardest conceptually to understand. So a water trough has 2 congruent isosceles trapezoids, so these two, as ends, and 2 congruent rectangles as sides. And then they didn't say that, but there's also a piece down here for the bottom of the trough. And I know that because these two sides don't meet each other, which means there's a little bit of space left, and there's a length for that space, so there's a rectangle on the bottom. They want us to find the exterior surface of the trough. So the exterior surface, not where the water is going to hit, but everywhere else, would have 5 shapes. And we're doing area. Surface area is just fancy for areas added together. So we're doing the area of multiple surfaces. So they already told us we have 2 trapezoids. We have 2 rectangles that are the same size. And then we actually have a 3rd rectangle that's on the bottom here. That's a different size than these other 2 that were the same. Okay. So when it says exterior surface area, they just want to know what the area of all 5 of those surfaces are. So again, this is why we don't have a formula for surface area. If you were relying on a formula here, you would actually miss this question, because in this case, there's no surface here. So the formula would give you the wrong answer, because it would include this surface. So you'd have to realize, like, okay, I need to subtract the rectangle at the end. But it's easier just to do the areas of all the shapes and add them together. It's less likely to make an error. Okay, so the trapezoid's area is 1/2 height. All right, so all these bases and heights are different, so just know that. So on the trapezoid, the height of the trapezoid would be this distance, and they didn't give it to us. So I come down here, draw the trapezoid. I'm just focusing on the trapezoid when I'm getting the trapezoid area. I don't care about the rest of the shape. So I only need to know the 8, the 5, and the 2 are the only things going to be drawn when I draw this trapezoid over here. So 8 is the top, 2 is the bottom, and 5 are the sides, because it's isosceles. So these are both the same. All right, to get the height, we use Pythagorean theorem, so we need to create a right triangle, so that's the way we can use Pythagorean theorem. And 8 is the whole thing. So these 2 edges will be the same. So if 8 is the whole thing and 2 is the rectangular piece, then the other two pieces have to be equal. So 8 minus 2 is 6 to split equally, so these are 3. So our Pythagorean theorem would involve 3 squared, h squared, and 5 squared. And the side across from the 90 is the c. Okay, so I'll give you a second to solve that out. You can pause it, whatever. But h will be 4. The bases would be the bases of the trapezoid. So the 2 and the 8 are at the top and the bottom. Okay, then we are on to the rectangle. So that was all for the trapezoid. So the rectangle, the two side rectangles here are 5 by 12s. And then the rectangle on the bottom is a 2 by 12. So 2 times a half is just 1. Times 4 is just 4. Times 10 would be 40. 60 times 2 is 120. And 2 times is 24. So we're going to be adding 40, 120, and 24. So the area for the trough would be 184 square feet. Okay, the volume is going to be, the volume for any prism, this is still a prism, is BH. And we already found the area of the base because these are the bases. The trapezoids are the congruent parallel sides, so those are the bases, so I'll shade that in. So the area of that was 184. And the height is the height of the prism. So it's not the height of the trapezoid. This H is the height of the prism, which is the distance between trapezoids, and it is 12. So 184. Sorry, this was not the prism. The trapezoid area, okay, so 1/2 4, so 2 times 10 was 20. Sorry, it's 20. I remember, I was like, I don't remember that answer. So 20 times 12. So 240 would be the volume of the trough. So the surface area of all the surfaces was 184. The base shape was the trapezoid. So I'm just pulling the trapezoid's area here, and then the height of the actual prism. Okay, if the trough is emptied until the water level is even with the mid-segment, there will be blank cubic feet of water left in the trough. Alright, normally with cutting some, like, you know, with, if you had a prism that was like a rectangular, like a square prism or a rectangular prism, if you were to take half the water out, it'd just have half the volume in it. But unfortunately for a trapezoid, there's actually more volume at the top, and you can tell that because this part of the trapezoid is bigger than this part. So if you cut half of the trapezoid out, or if you make the water level half of what it was, it was 4 inches high before, now it's, or 4 feet high, now it's 2. We're finding the volume as if the area, for the area of a 2, still the base is 2, so the base is 2. This was 8. So mid-segment means middle. Anything with mid means middle. So 2 and 8, the middle of 2 and 8 is 5. So this would be 5 units long. So we no longer care about 8 being the base, we care about it being 5. Okay. So again, when we cut off the top of this piece, this is now 5 units long because it's the distance 3 away from this length, and 3 away from this length is 5, so it's like the halfway point between 2 and 8. So we have a height of 2 and bases of 5. So the area of the trapezoid now is 2 for those, and then 5 and 2. So 1/2 of 2 is 1, times 7 is 7. So that's the area of the trapezoid, and now we're just going to times that by the height. So again, the formula is capital BH. The area of the trapezoid is now 7 instead of 20 because we took off some of the trapezoid. So it's not half of the trapezoid because half of it would have been 10. But it's a little bit less than half because this is a smaller piece than this. And then the height of the trapezoid of the prism didn't change. So 7 times 12 would be 84. Okay. Didn't put anything that hard on the test, but if you understand that, then you're well on your way. Okay, so number 7. A giant scoop operated by a crane is in the shape of a hemisphere and a radius of 21. The scoop is used to transfer molten steel into a cylindrical storage tank with a diameter given. If the scoop is filled to the top, so this means this hemisphere scoop is completely filled, what will be the height of the molten steel in the storage tank? So this is actually like your delta math problems where you had those 2 tanks, but they were both cylinders. In this case, you have one is a hemisphere being emptied into a cylinder. So they want the volume of this one completely to fill this one. And they want you to figure out what the height of this would be. So if you figure out the volume of this, that whole volume that's filled to the top is going to be poured into this, and they want to know how high up it goes if the diameter is 28. So the diameter is 28 here, and the radius is 21 here. So I'm going to come down here because I don't have any space there. So the volume of the hemisphere, I'll do it over here. The volume of the hemisphere equals the volume of the cylinder, because that's the same. All this is getting poured into this. Well, the volume of the cylinder of a particular height, the height that we're looking for. So now the cylinder isn't full, but they want to know how high up it's going to go. So they just care about basically how high this is if the whole thing gets poured. All right, so the volume of the hemisphere is 2/3 pi r cubed. The volume of the cylinder is pi, the radius of the cylinder is 14 r squared. So the volume of the hemisphere has to equal the volume of the cylinder, and we have everything known except for the height, so we're solving for h. Okay, so if we divide both sides by pi to start off with, the pi's cancel. All right. Then I'll actually evaluate this and divide it by 14 squared. So 2/3 times 21 cubed equals that number. So 6174 equals 196h, because 14 squared is 196. So divided by 14 squared, or 196, gives us 31.5. So the height will be 31.5 inches. They already wrote inches, but so basically you're just needing to know that the hemisphere is being completely emptied into the cylinder, and they want to know how high the cylinder would be, how high the molten steel in the cylinder would be. So you just put the radiuses in their particular shapes and solve for h. Okay, number 8, the solid below is a hemisphere with a 90-degree slice removed. Okay, so the hemisphere radius is given. So the hemisphere formula, they're asking for volumes, and they want us to use, this time they specify, so if it says use 3.14, the answer might be wrong if you don't. Round to the nearest digit means the nearest whole number. It's a weird way to ask it, but okay, 2/3 pi r cubed, and r is 8. Okay, so we're going to do 2/3 times 3.14, because they've asked us to use 3.14 on this particular problem, times 8 cubed. That would be the volume of the hemisphere. One chunk of the hemisphere is removed. So if we were to have the whole hemisphere, that would be the 1071.787. But a quarter of it's missing. So 90 degrees is a quarter of the circle, because remember the circle is 360. So we want to take away 1/4 of this, which really means we want 75% of this figure to be here. So we really want to divide this in quarters, to divide this in 4, and we want 3 of the pieces because we want 270 degrees worth. So we're going to divide this by 4, and times it by 3 of the pieces. So to the nearest digit would be 804. Okay. So really what you're figuring out is what percentage of this hemisphere has been removed, and 25% has been removed, so you're taking 75% of the remaining piece. So that's the same thing as 3/4. Okay, when a chunk of metal is dropped into a container of water, the water level rises 1.2 centimeters. The water container, or the container of water, is shaped like a square prism. Okay, so this has water in it. Let's just say it's got this much water. We don't know how much water it is. Then a chunk of metal is dropped into it. So we got a chunk of metal in the middle here. It's dropped into it. We don't know anything about the metal. We don't know if it's spherical. We don't know if it's cylindrical. We don't know what the metal looks like. But we do know that the water rose 1.2. So if we can find the volume of the displaced water, or the water that rose, then that'll give us the volume of the solid, because they're taking up the same amount of space. So the water that was there that was where the solid was, made the water line come up. So the water can't just disappear, it just has to move out of the way if something is dropped into the water. So this displaced water volume is going to give us the volume of this actual chunk of metal. So the volume for any kind of prism, the shape of the actual container of water is a prism, so you'd use capital BH, and the prism's base was a square, so S squared goes in for B. Alright, so the bases of the square are 4 each, so you put 4 here, and the height that the water rose was 1.2, so that means that was the height of water that was displaced. Okay, so 4 squared times 1.2 is, the volume is 19.2 centimeters cubed. They want us to find the density, and density is mass over volume. So if the mass was 52 grams, the volume is 19.2. We just divide that. So it's 2.7. For that. Okay, and last one on this. You work in the packing industry to make soup. Okay, so there's a can, which cans are going to be cylinders for us. So cans are 4 inches high. The can of soup is 4 inches high, and it has a diameter of 3 inches. Your department is asked to design a bigger soup can that will hold 1.5 times more. Find the height of the bigger can if the diameter stays the same. Okay, first they want to know what's the volume of the old can. So we're just doing the volume of a cylinder here. Volume equals capital BH for any kind of prism type figure. And in this case, the base is a circle. So we plug pi r squared times it by h. So pi, the radius is 1.5 if you cut this in half. So that would give us 28.27 is the volume initially. Okay, so what we want to do is, the department has asked us to design a bigger soup can that will hold 1.5 times as much soup. So if the volume was originally 28.7, we want it to hold 1.5 times as much soup. We need it to hold 42.405 cubic inches of soup. So we're working backwards now to figure out the height. So they've given us the diameter stays the same, which means the radius stays the same. And we're looking for the height. We're working backwards for the height. So dividing by pi, dividing by 1.5 squared gives us the height is 6 inches. Okay, so this test involves you being very familiar with being able to visualize these shapes. Some of them are not drawn for you. I had to draw 1, 2, 4 or 5 of these. 3. I need to know how to separate this one, so 4, I'll count it. So you have to really be able to visualize what shape it is. So that front of the worksheet, actually, we only spent one little, like, not even half a day, like 10 minutes on this. But identifying whether it's a prism or a pyramid is super important. And then based off of the base of the shape, that's going to go in for the capital B in the formula for it. So in the formula here, these are going to go in for the capital B of the formula, which I changed to an A on here because the A, it's really representing an area formula. So understanding the shapes, what they look like, so that you can be able to draw it and then solve for these things is super critical. Okay, the other thing that you want to do again is just flip through, make sure you're familiar with all of this stuff. You guys are going to do great. Okay, so I'll do a video for the other piece of this, which was the quiz.